Hello everyone, and welcome back to DevRay. So this is a follow-up video on the live sync between Oracle and Postgres. Today we'll be focusing on the other direction here, which is a live sync from Postgres to Oracle. By the end of this video, we'll have a fully functioning bidirectional sync between the two databases. Uh, so before we even begin, you might ask, what is the use case here? Why even have a bidirectional sync? Trying to keep these two databases in sync might actually be more of a risk. But let's just talk about a use case here where a live sync may be a bidirectional sync may be necessary. So let's focus on the business logic here. Um, so let's say this is a legacy, a company or a team has legacy code that lives primarily where they have business logic stored in the stored procedures, for example. And let's say there's a lot of business logic, a lot of stored procedures here. Um, and then let's say they converted each one over to Postgres syntax or Postgres stored procedure. Um, One approach they can do is completely cut over to Postgres. Um, Meaning that let's say the data is flowing only from Oracle to Postgres and then they converted all their procedures without fully testing it, and then they cut over to where their business logic is now living in Postgres. The high risk in that is that let's say there was no testing, maybe there was something that was not picked up. Um, Oracle to Postgres syntax may not be necessarily the same, and let's say it's heavy. There's a heavy logic, and they weren't on. They basically let's just say they missed something. Um, so during that time that they cut over to Postgres, data is flowing into Postgres, but does not flow back into Oracle. Now there's no clean rollback feature for them because the data was only flowing into Postgres. There's no bidirectional sync from Postgres to Oracle. So that's risk in itself is when they try to convert all their business logic and stored procedures. Something goes wrong, they can't go back to Oracle anymore, where the business logic was working completely fine. So that's one use case here. Is maybe they want to do a small rollout here, one business logic at a time. They want to convert and then test it into Postgres, but the data is still going back to Postgres here because ultimately the business logic in Oracle or the rest of the stored procedures in Oracle are still utilizing that data. Um, yeah, so that's possibly one use case here where a bidirectional sync can be useful, and can be it can ensure a gradual um, rollout to over to Postgres. So that being said, let's move on to the next slide. Um, so let's talk about the deliverables here. What are we building? So we'll detect the inserts, updates, deletes happening in the Postgres users table. And we'll push those changes via a consumer task into Oracle Advanced Queue as JSON messages. So um, if you have not watched the previous video from Oracle to Postgres, I suggest you do so. So because this will just be a continuation of that, and we'll still be utilizing the Oracle Advanced Queue um, as part of this deliverable. And then finally, we'll consume those messages with a Python process and sync changes to Oracle to the Oracle matching table. And now let's talk about the agenda. So we'll review the Oracle to Postgres setup. We'll quickly go over the existing code and the sync logic from the first video. I'll also cover some of the existing code already for the databases and some changes that we made for the Oracle live sync process. We'll set up the Postgres queuing system. So we'll create a queue table in Postgres, create after trigger for Postgres users table to add to the queue table, and we'll create after trigger for Postgres queue table to notify listeners. And the final agenda here will be creating the consumer process. So we'll create the Python process that will consume the post from the Postgres database define models and queries, implement a listen action on the queue table, and finally query the that was some spelling, but query the queue table and process record into Oracle Advanced Queue. So that's a lot, and it sounds a little confusing, honestly. But let's talk about the architecture here, how it might make a little more sense. So here we have the live sync process and the workflow. So some of this looks familiar from the last video as well. Is again, we're utilizing Oracle, Oracle triggers that. So any inserts, updates, deletes that are happening are captured in the Oracle triggers, or Oracle table triggers to be more precise, which connects to the Oracle Advanced Queue to store any updates. And then on the sideline, we actually have a live sync process that will read from Oracle Advanced Queue, or read any updates, and then ultimately process those updates over to Postgres. So basically, the workflow from Oracle to Advanced Queue to live sync to Postgres is what we talked about in the last video. What I want to talk about in this one is this new tab, the Postgres consumer. So what is missing here is that, so in the last time it was fairly simple to communicate to Oracle Advanced Queue because that's embedded into Oracle. So we can communicate directly from Oracle to Oracle Advanced Queue. So we can utilize that mechanism directly. Now the challenge here is Postgres cannot communicate with Advanced Queue directly. So we still need a mechanism, or we need a middleware here that will say, hey, capture my updates and then send it over to Oracle Advanced Queue. And that is where Postgres Consumer comes in. So Postgres will still utilize a similar approach, wherein we are capturing the inserts, the updates, and the deletes still in the trigger. But now that trigger cannot communicate with Oracle Advanced Queue directly. So that trigger will actually do something a little extra here, where we are creating a new table in Postgres called the queue table. And the trigger is actually capturing those updates and storing it in that queue table. And now Postgres consumer will actually read from the queue table to find any new updates coming in. So basically, Postgres consumer will be listening on Postgres, and if a new record comes into queue table, we're actually notifying Postgres consumer to say, hey, you need to query Postgres table now because there was an update. So Postgres consumer will now then query Postgres to query queue table, query the queue table, and then process those records and then pass it over to Oracle Advanced Queue, and then Oracle Advanced Queue will in turn be read by live sync process, and then the new part in live sync will actually be this read the destination of that update. So now it's either adding, updating, or deleting records in Postgres or Oracle. So basically, there is a new data that we have to add into Oracle Advanced Queue so that live sync knows where to post those updates. Is it either going to Oracle or is it going to Postgres? So now let's focus on the review here. Let's look at what we have built in part 1 and some of the changes that we have made to make sure that this bidirectional sync working. So let's start on the Oracle side. So we actually need to add a new column here, modified from Postgres, and this is for just one important task, which is on the update. So let me go back real quick to the architecture. So at some point, with live sync, for example, right? Live sync will accept an insert, update, delete over the Oracle trigger. So at that point, Oracle will just try to process the record. Um, so let's say the record came from Postgres, for example, right? Postgres goes through the whole workflow of adding a record, goes to the Postgres consumer, goes to Oracle Advanced Queue, then Live Sync will just send over that record to Oracle with the data that it receives. Oracle, in turn, will attempt to either insert, update, or delete. Um, and at the moment, it needs to know. It doesn't know whether it came from Postgres or not. It may even came from. It may have been being. The record may have been being created directly for Oracle as well, but it does not know whether it came from Postgres. So Oracle trigger will indiscriminately add to Oracle Advanced Queue because it has an update, and that's what we don't want, because at that point we could have an endless life cycle of record being passed over to Postgres, Oracle, and so on. So basically, at the trigger level, for both databases, we want to know whether this record was created from Oracle or was it created from Postgres. If it was created from Postgres, then yes. Let's say, okay, just to be more specific here, let's say a new record's coming into Postgres, a new record. Okay, so if it's coming directly to Postgres, it doesn't exist in Oracle. So the trigger needs to know that this record is only in Postgres and now must go through the whole cycle so that it can make it back to Oracle. But if it was made in Postgres, we don't want it to go back to Postgres. That's an endless cycle, particularly with the update. That could be just an endless path that we don't want to continue. So basically, if the record is coming from Postgres, makes its way back to Oracle, Oracle in turn should not add that back to Oracle to the queue, because otherwise, these two will keep attempting to add that same record back to Postgres and create an infinite loop here. So, particularly with insert and delete, Postgres will actually throw an error because A, the record has already been created and we can't do a primary key, that's a primary key violation. Or B, the record has already been deleted, there's nothing to delete. So in other words, nothing will cause the trigger to add back to Oracle Advanced Queue. But what will cause an issue is the update. Update can endlessly send up an endless loop here. So basically, going back now, we basically want the trigger to have a way of knowing when to add to queue. And this is where modified from Postgres comes in. And we are adding a new column in the users table just to help indicate that. It can be a simple one as a car, whether it's either on or off, right? I mean, whether it was modified. So if it's not modified from Postgres, obviously is 0. If it's modified from Postgres, it would be a character of 1. So with that being said, this is part 1 in Oracle. The part 2 is modifying our triggers to read from that modified from Postgres. Also, on top of that, we want to modify our JSON data now. We want to include that additional column so that it can be passed over. So on top of the JSON data update, we want to ensure that we are passing modified from Postgres in all instances. And before that, actually, we can just read off modified from Postgres, and if it's 0 in this case, that means the record was created in Oracle. So we want to send that back over to Postgres. Let's say it did come from Postgres, the value would be 1. In other words, we don't add it to the queue. So it's just a simple conditional check here. It's if we're checking on modified from Postgres, if it's 0, that's the only time we add it to the queue so that it can be added to Postgres. As far as for the Oracle changes, that's pretty much it. Let's completely focus on Postgres because this is a lot of changes that we've made. But similar to Oracle, what we want to do is alter the users table and add modified from Postgres. But the only difference this time is we are defaulting to 1. So if for some reason it's coming into Postgres as null, that means the record is being created particularly for Postgres. Step 2 is now that records can be created in Postgres, now we're accounting for that situation, we want to adopt a similar approach as we did in Oracle. Because in Oracle, we were just utilizing a sequence here. We're not auto-generating those primary keys. So we're creating the sequence here as well in Postgres. And now, so similarly, we're creating a trigger function here for users table before trigger that will set. So if a new record is coming in and if it's null, it's just utilizing the sequence to grab the last number. So we create the trigger function. The step 4 is to attach that trigger to the users table as well. Pretty straightforward. Now the key thing here is now we're creating a new table. This is just particularly for Postgres. We're creating the Q table with a few columns here, and think of this as a similar approach to Oracle Advanced Q. So the Q ID is just auto-generated. We don't really care about that. We care about the status, whether it's being processed or not, how many times this has been tried, create time, update time, when this was actually processed, and this should start looking familiar. The action, table name. So action meaning it's either insert, update, or delete. Table name is, right now we only have one table, but we can keep it flexible. This will just be the user's table. And the important one is destination. So this will say, this should actually just be defaulted to Oracle. So we don't have to worry about too much on the Postgres side. Because if an update's coming into Postgres, we ultimately want that destination to go back to Oracle. And then the Q data will contain all the table's information. Step 6 is we want to create the trigger to notify listeners. So this is particularly, so this is what I mentioned earlier. So basically, notify consumer will send a notification to all listeners, and they'll be listening on the Q channel. Just to keep it simple. And then the second argument is just to say, it's a placeholder right now to just say it was modified. And now we are attaching that notify consumer to the Q table. So anytime there has been an update or an insert on the Q table, so we basically want to signal the consumer to say, hey, there's a new record there has been an update on the Q table. Do a query on the Q table and then process the updates and then send that over to Oracle. And then finally, actually not finally, so next step is to create a trigger function that adds to the Q table. So this will be in charge of, so this is essentially the trigger that can be utilized by all the tables. So add to AQ, similar functionality here is, so this is a dynamic approach. Let me expand this. Should have done that earlier. Apologies. So we tried to make this dynamic. So essentially all the tables grab all of the columns in that table and then loop over to get the data and then store it over to JSON. And we briefly talked about this on the Oracle side, is we are also checking if that JSON object, the value of modified from Postgres is 1, then yes, we want to add that to the queue. We want to insert to queue to signal the consumer to add this back to Oracle. Otherwise, if it's not 1, that means it came from Oracle, right? So we don't need to do anything else. The job is done. and then this is just a placeholder again. So Postgres effortlessly needs something to return for the triggers, and this is just a placeholder. We don't really care about this. We won't use this too much. And then the final step here is to attach this trigger to the user's table. So at the end, if an insert, update, or delete happens after trigger kicks in, and then it adds to the queue. Okay, so I said a lot there. Feel free to rewind the video if you need to go over, because some of these syntax, these setups are important. But let's move forward here. So the next step yeah, so apologies. Next step. So again, I did all this setup already. I ran all these on the database portion just to save some time. Now I want to focus on creating the consumer. So going back here, going back to the slides so that we have an idea. So now I want to focus on the Postgres consumer. We've already set up Postgres and Oracle with those changes in mind. Actually, let's go back. Before we jump into Postgres consumer, let's also talk about the changes we made to live sync. Okay, so this is the same repo that we had previously in the last video. So let's start off with models. Again, since we're adding a new column here, modify from Postgres, we have to declare that as well so that we can pass it over. So Oracle AQ it's relatively the same. We don't touch the AQ connection. So now we have an Oracle DB and we have a Postgres database, because now Oracle Postgres sync will ultimately manage the bidirectional sync. So it needs to communicate with Postgres and Oracle separately. Apology, I think we had Postgres DB already. I added Oracle DB. So now we have to connect to Oracle DB so that we can add the new records. Okay, nothing has changed in the requirements. As for run sync, also nothing has changed. The sync task, we had to make some configuration changes here. So again, we needed to know the destination here. So we added this. It should be coming from Oracle Advanced Queue. Now that we made those changes, so that value ultimately will tell us where this record or this change will go now. So this changes. We also added an additional check here. So this was our code from last time, and this was a Postgres specific syntax. So we don't want to use that if we needed to add a record to Oracle. We just wanted to use the plain simple insert, and we're just doing a conditional check on this one. It is checking the destination. If it's Postgres, use the old one we had. Otherwise, you're using the new. And then going back to the same, these are what we had before. The session changes. So again, I added Oracle session here, or Oracle DB to be precise. And then we added an additional check here. So which session are we executing these insert, update, deletes from? And if the destination is Oracle, or session, if the destination is Oracle, otherwise we're using Postgres session. So relatively simple. We just added a few line changes here, and as well as a new file to connect to Oracle DB. So now that we covered the changes from the last video, let's start with setting up a new task called Postgres consumer. All right, so all these files are mostly empty. This time around, I wanted to focus on config, just so we are aware of like what configurations I'm using and how I'm using them. So Oracle DSN, is the Oracle connection in the format of the user, password, and whatever the alias name is in TNS. I don't want to focus too much on some of these configurations, otherwise we'll lose track of the focus of the video. I just wanted to focus on like what variables and what they stand for. Postgres DSN is similar, so we're utilizing PostgreSQL as well as the user, password, port, and the database name, Oracle Instant Client. We need that to connect to Oracle. Hopefully you have that installed, and then essentially that's just a path to where your client or Oracle Instant Client is installed. Oracle AQ name, probably should have left that the same. So whatever we connected or whatever we created from the last video, it still remained the same. So user changes Q. The config dir. It says path to Oracle wallet. So I think I neglected to mention that I'm utilizing a Oracle wallet approach here. So I'm connecting to Oracle completely based on the wallet approach. And then finally is the Postgres connection string. So I think I figured out, or I came across the issue where I can't utilize a Postgres DSN to connect directly to Postgres, so I had to utilize the old approach of Postgres connection string. What I mean to say is, like establishing a raw connection, it would just wouldn't accept the Postgres DSN format, so I had to use a separate connection formatting, which is a PostgreSQL, the user, port, password, database name. Okay, so a lot of these I'll change in the background so that I'm not trying to share some of my credentials here. So yeah, okay. So let me do that real quick so I don't forget about it and then have to debug it later. Okay, let's X that out. Okay, so let's focus back here. So the next thing we want to focus on here is the models. The only thing the Postgres consumer cares about is the Q table. So I'll just copy and paste what I had already just to save time. So I'm just redeclaring all of the types that was defined in Postgres database over here to Postgres consumer in Python. So we have the QID, status, try count, create time, update time, process end time, action, table name, destination, and Q data. Nothing overly complex. We're just defining the models here. This wouldn't be communicating directly to Oracle in any way, so this table would not be used in Oracle. So Oracle AQ. We'll go back to that one actually. So basically, this whatever logic we defined here is the logic that will handle adding to Oracle AQ. So this is the communicator between Postgres consumer over to Oracle AQ. Postgres database, let's focus on that one. Pretty straightforward. We're just establishing the connection. Requirements do not change. We're still utilizing SQL Alchemy, Oracle DB, and Scicop PG2 binary. And then run sync. We'll fill this in a few. And then let's go over sync_test.py. Okay, so again, like I've done a lot of this beforehand just to save some time, but I'll cover each line just to make sense of what it does. So first one being get queue record. We initially set the queue record as none. Now we do a session.begin here just to begin the transaction. So, and then we do a select on the queue table. I think I neglected to mention why 0. So just for uh, just for the sake of clarity here, let's just assume that 0 means that the queue record has not been processed yet, or no one's even looking at it. So 0 just means the default setting. Uh, and then we're ordering by QID, ascending. Just for fairness, again, first in, first out, that should be the process in terms of the order. And then with for update, I think that's a very important code here, and skip locked equals true. So before I even jump into the rest of the code, let's go back and discuss the architecture here. So right now, if we have only one process, or let's say one task running, it doesn't matter too much. But in the grand scheme of things, if you're thinking of scalability, Postgres consumer maybe can run separate instances, maybe on separate machines. And ultimately, again, what Postgres does, particularly the queue table on the after trigger, if anything, if there's an insert or update that happens on the queue, a signal gets sent out to all of the Postgres consumers listening in. So we can have potentially 8 instances of Postgres consumer running, and all of them will attempt to query the queue table in Postgres. And now how that could be dangerous is if all of them, they could all potentially query the same record. So let's just say, assume that there's an ID of 1, a queue record with an ID of 1. They could all potentially query that, get the same record, process it, and then send it all over to Oracle Advanced Queue. And then Oracle Advanced Queue can, as a high risk here, can all send it over to Live Sync and then send the 8 duplicate records to Oracle. Right now, our Oracle table and our Postgres table, they have constraints, primary key constraints, so we cannot send duplicate records. But let's say a table does not have those constraints, primary indication, we could potentially destroy the database here with the dirty records, and we don't want that. But unfortunately, there's no way Postgres consumer can say, "Hey, we're all querying the same records." Neither can Oracle Advanced Queue know that. They're just all programmed to query, process the record, and then send it over to the opposite database. So going back, what with for update skip lock ultimately does is whoever queries that one record first ultimately has a lock on it. So that means the first instance of Postgres consumer to hit it has a lock on that record for the duration of that transaction. And the other 7 instances will just query and see that. Basically, they will not see that one queue record because it's locked. And the importance of that is, what happens here is now we execute that statement. So that one queue is locked in for this one duration, the rest of the duration. What we're doing here is now ultimately we're just setting the status of that queue record to 1. And just for clarity, 1 means it's being processed. So no other record here can actually query that. And then we're immediately updating it in the same transaction. So that next time someone else tries to query it, they can no longer have access. They will no longer be able to see this now because the status is 1. And then we're processing that record even in this one instance. So just to review, what this whole code does is one instance basically locks a record for the queue record, locks the queue record, and then immediately updates the status to 1, so that ultimately no other Postgres consumer instance can process it. And then we have delete record, pretty self-explanatory. So when a queue record has been processed and added to Oracle with no issues, then we're going to delete it from the queue. And then update queue record try, relatively simple as well. So basically, we're just querying that. So this happens when the Postgres consumer tries to communicate with Oracle Advanced Queue, passing it that queue record, but something goes wrong. We don't want to just leave that queue record in limbo. We want to put that back in circulation. So we're updating it back to 0 so that others can try to process it, but we're also increasing the try count here. There's an indentation issue here. Let's fix that. Yep. So we're basically putting back that queue record back in circulation. Right now it could potentially fail forever, taking up processing power, but for now we're keeping it simple. We're just putting it back in circulation. Okay. So now we have sync task, run task. Actually, let's go back to Oracle Advanced Queue. So now this is the most important part. Is now that we have those logics in mind. So yeah, we're initializing Oracle client here. We're establishing the Oracle engine. And then we're creating a function called process PostgreSQL. So now that's, this is the bulk of the logic here. So we are getting the queue record. If there's nothing, we just return there's nothing to do. Queue ID, we connect to Oracle Advanced Queue. Get a raw connection. Basically, we're just setting up the type here. Again, it's just a JSON text message here. And we're connecting to the queue. And then we're setting up the payload. We're setting up the new object. And then we're setting the text VC. So this is basically going to be the contents. And then we're formatting it into JSON object here. So whatever we get from the queue record, we just need 3 important things here. The destination, the operation, as well as the data. So that's all being stored as a JSON format in the payload. And then we're setting the message properties and then passing in the payload. And then the ultimate step is we are adding that, we're adding to the Oracle Advanced Queue whatever we got from PostgreSQL. And then we commit. And as mentioned earlier, if nothing goes wrong, we get to this step, which is we're deleting the record in Postgres. Otherwise, if there's an issue, we hit the breakpoint here, we can debug it, but ultimately it's just going to retry and put it back into circulation. Okay, so we have the core logic here, or OKQ. So now we can attempt calling it from run sync. Let's go back. A few important steps that we need to establish here. Let's import a few things actually. We'll do this line by line. So we'll import the Postgres connection string. Again, we need to do that for a raw connection. Select psycop G2 and some extensions, and then process PostgreSQL. So as much as I want to explain these two, these I got from documentation. So again, we're establishing a raw connection here to Postgres, and then we're setting the isolation level to auto-commit. And then the core, the logic here in the try else block. Forgot one thing. We can manually define that here. Timeout 2 seconds. All right, let's go through the core logic. So with our connection, we get a cursor. And then, as mentioned earlier, this instance will now be notified by Postgres, the trigger. And this will be listening on that trigger. So this is the core logic that we need to listen in on that queue. The name of the notification that we set in Postgres is queue. So we're listening in on queue. So basically select here. This is a backup process. So this is the core logic. So we're polling Postgres, and while it notifies, it's basically going to send us a notification here. So if the record comes in, if a new record comes into the queue table in Postgres, it's basically signaling our consumer to now process that new record, or basically to query the queue table. Now the first if is more of a timeout. So let's say no new record is coming in, but the queue is not empty. Let's say a new record was not processed, or basically just there was just a record that got into the queue table that just did not send a signal. So this timeout is our backup process to just queue, just to make sure that there is nothing in the queue table there at all. So just to recap, so we have an if-else statement, it's basically a timeout that forces to query the table queue table just in case. Otherwise, we're listening in on Postgres signal. So with that being said, now we have the core logic for Postgres consumer. We can run this. Let me go from a virtual environment and then run the process. Okay, so now it's running, it's listening in on queue and processing because there's just, we're checking a length type and there's not nothing was returned. So let's, how do we test this side by side? Okay. So simultaneously we're running Oracle Advanced Queue on the right side and Postgres Consumer on the left. So the best way to test this is to add records into Postgres. And then let's set up Oracle. I already have records here, just to be sure. And then right now, these should be the same records in. Oh, apologies. Querying from queue. We want to query from users. So the users table should ultimately have the same amount of records. Or a little more actually. I did more testing here. And these were some of the ones that didn't go through because there were some errors. So just to keep it simple, let's start with a blank slate here. Or rather, let's test this out. So delete all from users. So ultimately, this will send a signal that all these records should be added to the queue. And then queue will send a notification to the consumer that will be processed and then added to Oracle Advanced Queue to delete the records in Oracle. So let's see. Being a little optimistic here, let's run all this. Or wrong syntax. Delete from users. Okay. So no issues. I guess no issues in the Oracle trigger. I mean the Postgres trigger side. Let's build up the suspense here. Any issues here? Okay, so the left side, okay, so the records have been processed and then changes are being received in Oracle side for delete, right? Ignore these two. So basically, does our log say it? Okay. I don't know why our logs doesn't say it on the left side, but, or maybe it does. Let me see. Interesting. Okay. Well, anyways, this is getting it, right? So let's just assume that something else is running in the background. Maybe I might have an instance I didn't shut down, but basically, this is running. Postgres consumer is reading it and passing it over to Oracle. So let's just confirm that Oracle actually got those, and all these records should be gone now. Huh. Oh, okay. So I don't think this existed actually in Postgres. So this won't get deleted. Yeah, okay. So just an edge case. All right, so now let's confirm this. Let's do an insert. We'll go back to delete again just to confirm. So if we do an insert here, giving an ID of test, name test, email of test. Let's just query Oracle. Oh, okay. Let's see. Let's debug this real time. What's the issue? Or, okay. Okay, I think I got too premature concern there. So that's fine. So it eventually got it and processed it. Just trying to confirm on the logs here. I don't know why I'm not seeing it. I mean, something is processing it. Okay, let me shut this down just for... Okay. I just want to confirm. So Postgres consumer is not running right now. I just want to make sure I don't have an extra instance running somewhere. So if we were to do so this is gonna throw an error. So let me try another insert. And if nothing is running, there should be something in the queue. Okay. Okay. So the record we just added, and just to make sure, let me run this again. Try count. Okay, so all right. Just to confirm. So I think it was running. I don't think we just had logs to confirm it, but let's try that again. So let's run the sync. So this will time out. Now it'll try to... Okay, now if we go back, again, I think I'm missing some logs here. That's fine. We just need to confirm whether this is now changed. Okay, so just to avoid the headache, Postgres consumer is doing its job. The logs just don't notify it. That's fine. Okay. For super sanity check, let's put this in the same window so that we can read it. Okay. Now I want to delete all the records from users. Huh. Okay. I guess we just do not have logs. But Oracle is indeed getting them. So let's not stress about this. Okay, I don't want to spend too much additional time on this. We have our process working. I do just want to test one more thing. So let's re-add this. Let's put this back. So let's re-add this back in Oracle. Then let's confirm. Okay. And now I just want to update users, set name super test where hope I call that ID equals 11. Okay, and now this should also reflect super test. Okay, so we have our whole process working. Insert, update, delete. We now have a full bi-directional sync between Oracle and Postgres. So yeah, okay. So that's how we achieve a lightweight bi-directional sync using native features like Postgres triggers and Oracle AQ. Any questions, feel free to ask in the comments. I'll try to get back to you. Thanks for watching. If this was helpful, don't forget to like and subscribe. And yeah, again, if you have any questions, feel free to add on the comments. I can get back to you. Thank you for watching.